Hello again and welcome to lesson 2 of Games Programming. So last lesson we left it with a very simple program where you would just see a message telling player 1 to get ready, and you would press a key and it would make a sound. So hopefully it was intuitively obvious that these lines are carried out one after the other. But if that wasn't clear, or if you want to get prepared for the next section, we'll talk more about that shortly. So first thing is, that sounds pretty annoying, so I'm going to change it to a 2 kHz sound for maybe half a second. That's a minor thing, but never mind. Okay, so we're going to improve this by having it welcome you by name. So after the beep, we are going to write a line of text out to the text console saying please enter your name. We'll then need a string variable to store your name, and we'll give it an appropriate identifier, player name. And we're going to assign that a value which we're going to get from the console. The console is going to read a line of text from the keyboard, and it will return a string which will assign to the player name variable. Next, we're going to tell the console to write a string of text saying welcome. Now you'll notice it's write and not write line, so it's going to write this piece of text and it will still stay on the same line, so that when we then say console.write again, it's going to add something on to the existing line of text, which is going to be the player's name next. We're not quite finished yet. We'll also have console.write, console.readKey, otherwise the program will just disappear before we see anything. So let's start that in debug mode. Get ready player 1, press a key to start, and it'll say enter your name. Welcome David. There we go. Press a key and we're done. So the reason we're doing this is to show you the idea of concatenation. Now this is another operator. We've used 1 or 2 operators so far, but this is another one where you can join 2 strings together. So the first string is this one here, the word welcome, a comma. And concatenation is done using the plus symbol, same as you would add together 2 numbers. You can't really add together 2 strings, so the closest thing is to concatenate them, stick them together. That will do the exact same job. It's going to write the word welcome followed by the word player name. Just in case you don't believe me. Welcome Bob. Okay, so that's concatenation. And there's lots of other string commands you can carry out. We're not going to go into detail about them at the moment, but you can add letters in, you can remove letters, you can find whether a string of text contains a particular substring, things like that. But we'll not use them right now. Instead, what I'm going to do is open a project I made earlier called Madlibs. If you're not familiar with Madlibs, the idea is you find a piece of text and you replace words in it with words that are randomly chosen by the player, and hopefully resulting in something a bit amusing. So let's enter a noun, plural noun, an adjective, a nationality. I don't have a person to my right, so I'll just have to put myself in. Something that's round. Okay, so we've entered a whole bunch of variable data, and it's going to use that in a pre-existing bit of text, which I stole swiped from Wikipedia, describing a famous painting. Oh, I forgot a number. Number 69. No idea why I'm choosing that number. 400 years ago, people thought the Earth was the centre of the entire trumpet, and that the sun and all of the shorts revolved around it. But then a furry Italian astronomer named Marshall discovered the truth. In fact, the Earth revolves around a pizza 69 times a year. So that's about the simplest game you can make. Press enter to finish. And it's just one command after another in a sequence. They're carried out as they are here. So the first thing it does is declare some variables. welcome you to the game and asks you to type in the first word, then waits for you to type in the first word and stores it. Please type in the next word, stores it. Next word, stores it, and so on. It's going to keep on asking for words, and then it gets to the next phase where it starts writing stuff out to the screen, one after another, in that particular order. If I mess with the order, let's say if I cut this line of text and put it up here, and then I run it, I'll get things in the wrong order. There we go, there's where the variable should have been, and it's not there because we're doing things in the wrong order. And I've got cat dogs, which is some weird animal that I never want to see. So that's because these lines, these statements, were in the wrong order. I marked them around. And that can easily cause problems in your game logic. You'll notice the game still ran. There's an error there. There was an error there, but the game still ran. And so there's different types of errors. Some that will stop the game from even running, and some that will make it run, but it'll just go wrong. Again, more on that later. So what I'm going to do here is expand on this start button here. There's a start button where you can run it in debug mode or in release mode without the debug information. But if you click on the debug menu, you also have the option to step into your code, or you can press the F11 key for short, which I'm going to do from now on. So press F11 and you'll start your game. By the way, you can also click this button here. So it starts on this yellow line. The yellow line indicates debug mode, and we're on that line. That line's not ran yet, it's about to. When you press step again, it runs that line and moves on. You'll notice it skipped over this line here. Declarations are not executable code, they're just setting aside space for variables, so that doesn't really carry out any processing. The next line that does that, the next executable line is here, so it jumps here. And if we step into here, can we tab to the window? Yep, we can see after running that console.write, we have welcome to Mad Libs on the screen. Step over the next line, and it'll have more text on the screen again. Now, next thing it's going to do is read a line, so when we press step into, the window will stay open waiting for us to do that. As soon as we enter that bit of text though, back into debug mode. But now, things you can do while it's in debug mode, we can see that this noun variable now contains that piece of text. We're inspecting that variable as the game executes. You can also do things like if you right click on it, you can add a watch, and the watches that appear down here, watched variables, you can view even when you move on to the next line. And these kind of things are useful for debugging your program when things go wrong. But it's also good to just illustrate that things are going in a sequence from top to bottom. Let's read the next line. Print the next line. Another thing, by the way, if you're getting bored of doing this, you can put in a breakpoint. So if I scroll down to the start of the next chunk of code, which is where we're really interested in, and click on this little grey bar, the line turns red. That indicates a breakpoint. What that means is when you press continue or start, it's just going to keep processing until it gets there, and then it will go into debug mode. Right, we've reached that point in the code and it's entered debug mode. We can now step through it one line at a time. We can view variables as we go, but that's by the by. Sequence. One line after another in that order. I recommend you get used to using the debug commands. They are extremely useful for fixing errors, and also even if you just want to see the way your code executes. Anyway, but that's just a slight detour. Let's go back to our Ready Player One solution. Okay, so what we're going to do next is show you how to use a few variables. So after entering your name, next thing I'm going to do is ask you to enter the score. Obviously, if this is a real game, you would play the game and gain a score that way, but we're going to cheat and just type in our score. So the text that the player enters is going to come from the console.readline again. And then we need a score variable, which is separate. You can't type in a number. It might look like you're typing a number, but you're actually typing a string. So we need to take that string of text and convert it to a score, because if we say the score is text entry, it's not going to let us do that. It turns red saying cannot implicitly convert. We'll explain what that means later, but basically it's saying this is a string, you can't put a string into a score. Even if that string happens to contain, I'll comment this line out. You can put a comment in, by the way, and it will turn code into non-executing code. That's called commenting out. You should never leave it in there. You should always take the comment back out when you're finished, or get rid of the line entirely if you don't need it. But it's good temporarily. So if we were to enter a score, oops, I should have worked on the spacing there really. Even if I put in the number 300, it goes in as a string. If you don't believe me, let's do that. Oh, what's happened here? Oh, I put the debug at the wrong point. It should have been after that line. So continue. And there's all the keys I pressed earlier. So when I type in the number 300, text entry contains, you can see it's got 300 in quotes. So it's a string, it's not a piece of text. So we can't take that string, even though it's meant to be a number, and turn it into a number, or can we? Well, there's another class, like the console class, it's contained within the system, called convert. And if you use the convert class, you can say convert to an integer. There's three types of integers, the basic one is int32. Convert to integer, what are we going to convert? We can convert a boolean, byte, character, date, etc. One of these will say string, I'm sure. If we go through it. There, you can convert a string. So the convert method just converts various different data types from one to another. So we'll convert text entry to a score. So now that we've got a number, let's muck about with it. Why don't we get another number from the console? Let's get some bonus points for completing the level. Oh yeah, I wanted to put in a new line here, didn't I? So we'll change that to console.writeline so it doesn't mess up the spacing. But yeah, so enter the bonus points for this level. I forgot a semicolon, so it's mucked up my indentation. So another integer for the bonus. And text entry, we're not declaring it again because it already exists, but we're going to assign a new value to it, which is console.readline again. And once that's done, the bonus is equal to that text entry, convert to int32 again, text entry, and that will give us a different value because we've read in a new value from the console. So we've now got a score and a bonus. We can now say score equals score plus the bonus. So we're adding the two together, score and bonus, and whatever that comes to, whatever that expression evaluates to, we're going to assign to the score. So let's say score is 10, 10 and bonus is 5, 10 plus 5, and assign that 15 to the score. So the score will become 15. But let's just finish this off. Console.writeline. Total score is concatenate in the score value onto that string, and it's going to convert that to a string for us automatically, by the way. So we'll end up with one big long string that contains a number. pressed F5 there, by the way, in case you were wondering. F5 is the same as start. So Steve's score is 100, and he got bonus points 50 for this level. Total score 150. Simple enough. But that demonstrates various operators and conversions there. Convert, plus operator, concatenate operator. And that's integers in play as well. So the score was an integer, a whole number. But you can also get numbers that are not whole numbers. These are real numbers, mathematicians call them, and programmers call them floating points. Floating points can be single precision or double precision. We're going to work with single precision floats by using a multiplier. So enter your current score. Where's that? Here it is. Enter your current score, into the bonus points, and then we're going to add in, just before we write your total score, we're going to ask the player one more thing. Enter a score multiplier for this level. Use text entry again. And then, sorry, no, not integer, float I said, wasn't it? So the floating point value called multiplier is going to be convert, but not to integer this time, to a single precision floating point. And we're going to convert the text entry to that. Also, the score calculation is going to be different. Let's move it down here, cut and paste. Score, it's no longer just score plus bonus, it's going to be score plus the bonus times the multiplier. Oh, it's gone red. What does that mean? Cannot implicitly convert type float to integer. So we've got this floating point here and we want to do something with it and store it as an integer. It can't do that, not as standard. So we need to convert this multiplier, well, one way to get around that would be to convert that multiplier to an integer. Here's how you do that. That's called a cast. It's kind of molding that float into a different shape. That's why it's called a cast. And it's casting it to an integer. Whatever you put inside the parentheses, that's your cast. So that gets rid of the error, but isn't that what we want to do? Why are we bothering with a floating point if it's always going to be treated as an integer? So if we put in a multiplier of 3.5, it's going to convert that to an integer. It's going to drop the 0.5 and you just get the 3. So why even bother? There's a better solution. Instead of casting here, we can do this multiplication separately and then convert that to an integer. But we're going to like that. Let's see, let's build it. Yeah, that seems to be okay. It must be automatically converting this bonus from an integer to a float, because you can then multiply two floats together. And we end up with a float, you can then convert that to an integer. Why is that better? Well, if your bonus, let's say, is 100 and your multiplier is 1.5, then it will actually multiply by 1.5 instead of by 1, and you'll get 150, which can be converted to an integer without losing anything. So to demonstrate, let's do it the first way, the not so good way. We run it. Current score is 100, bonus points another 100, and the multiplier 2.5. So 2.5 times 100 should be 250. Add that onto 100, we should get 350, but it's dropped that 0.5. So our bonus was 200 onto 100, which gives us 300. That's why that's wrong. So let's do it the other way. Remember BODMAS, brackets, ordinals, divisions, multiply, add, subtract. So the brackets come first, and then convert it to an integer. Let's try it that way. That's what we expected. So that's a better approach. And what we have there is two kinds of things going on. We have a bonus being turned into a floating point for us. We don't have to do that. And then multiplying it by another floating point. Because you can't actually multiply a float directly by an integer. But the compiler is smart enough to know that you can very easily turn an integer into a float and then do that multiplication. So it's doing it for us. It's called an implicit cast. But the result is another floating point which you cannot add onto an integer. So we need to explicitly tell it to cast into an integer. So that's implicit and explicit casting. Okay, the next topic is, the next data type to cover is booleans. And we're going to add a boolean to figure out whether you've beaten the high score. Let's do that. I think we should do that here probably. Let's set the high score as 100. So I'm going to put in a literal value of 100. Not a good idea to stick magic numbers in that if you can avoid it, but this is just a demonstration. And a boolean, which tells us whether you've beaten a high score or not. And we're going to assign a value to that, a true or false value, which we'll get by evaluating whether your score has beaten the high score. So it's kind of an odd looking line there. We do this comparison first. There's another operator, by the way, the greater than operator. Is score greater than high score? And that will come back true or false. Yes, it is greater, or no, it's not, true or false. And we're going to assign that true or false value to this boolean. And if you have beaten the high score, so if that value is true, then it will run this bit of code. We were talking about earlier about sequences. Well, this is the next type of flow control. It's called selection. We're selecting whether or not to run this bit of code. It will only run if that beaten high score boolean is true. If it's false, it jumps straight to the next line instead. And hopefully I can demonstrate that with a debugging later. So if you've beaten a high score, then we're just going to congratulate the player. Console.writeline. Well done, new high score. Going to put a full stop in, but that's not good enough for beating a high score. Okay, so I'll stick a breakpoint in here. And Ted is going to get a score of 10 with 0 bonus points for this level, so it doesn't matter what the multiplier is, total score of 10. And we've now reached this debug point. Score is 10, high score is 100. Let's step on to the next line. After running that command, beaten high score is false because 10 is not greater than 100. So if we beaten high score, we run this code. Well, we haven't, so it jumps straight to console.readKey. And there's the end of our program. But let's say we did beat high score. It's me, of course I'm going to beat high score. Is that right? 300, 200, 500. I guess that's about right, yeah. So when I press space, have I beaten the high score? Well, my score is 725. That is greater than 100, so that should come back with a true value and store the true value in here. It did. So if brackets true, then it should run this code. And it does. There we go. I can ignore that for a moment. And after it has run that code, it still carries on where it would have been if it was false. So this is kind of like an option. It can run or it might not, depending on that condition. Either way, it continues on the next command after it. So the sequence continues after the end of a selection. That's always the case. Right, so there's more we can do with that though. For example, this variable is kind of odd looking, and in fact we can simplify it. If we copy and paste that in here, we can actually get rid of that variable entirely. So instead of storing the result of that comparison in a variable, we can do the comparison directly, and the result of that Boolean true or false comparison will determine whether we run this code. Exact same code, except that we don't store a variable. Another thing we can do is we can put in an alternative consequent, and we do that using an else statement. So if you haven't beat the high score, tough luck, but here's a bit of text commiserating. So these are both consequents. If the expression evaluates to true, then it will run this consequent. If the expression evaluates to false, then it will run this consequent, the else part. So one of those two will always run, and whichever one runs, it will continue after it on the next line. Demonstration. Change beat the high score, well done. Ted obviously was on his coffee break, he got no score. Bad luck, no high score today. So it runs one or the other depending on whether you've beaten the high score. Alright, now you can actually do multiple if statements. So I'm going to demonstrate that by using a cheat mode variable. In fact, I'll scroll up to the top, see that bit where we start the game, the read key. We will change that so that whatever the read key comes back with, we're going to then convert it to a. We're going to get the character. Get the character for the key that was pressed, and then assign that. So key char is, if you hover over it, it is a character, and I'm going to assign that to a character variable, which I'll call input key. So if input key is equal to, that's the equality operator, is it equal to, notice there's two equal signs. So one equal sign to assign something, two equal signs to compare something. Easy to get them mixed up, I'm sure you all do it at some point. But anyway, if you've pressed the capital C letter, then we'll need a boolean. Cheat mode enabled, which will be false by default, but if you press the letter C, cheat mode enabled becomes true. Oh, and I've put the C inside quotes, which is a string, not a character. So that's more like it. So you can press C at the start to get cheat mode. And if you beat the high score while in cheat mode, we then check. Sorry, if you beat the high score, we then check if you were in cheat mode. If cheat mode is enabled. In fact, let's do it if cheat mode is not enabled first. So if cheat mode enabled is false, then you still get the message saying well done. But if cheat mode enabled is not false, in other words, if you are in cheat mode, then it will say console write line. You beat the high score. Unfortunately, you will not be entered into the high score table. Since cheat mode is enabled. Okay, let's start that. Bob's a filthy cheater. Oh wait, I pressed the wrong key there, I didn't actually press cheat mode. So if our current score is 300 and we get 200 points for this level, we get a new high score. Fair enough, but let's now do it with cheat mode. There we go, cheat, C for cheat mode. Okay, Bob's not a cheater, Steve is. He gets 4,000. You get a high score, but you'll not be on the high score table. Okay, there we go, so that works. But look at what's going on to make that work. One if statement inside another. Inception there. The code here all runs only if you've beaten the high score. So if you've beaten the high score, it checks then if you've also got cheat mode enabled. So it will still run one of these two if you beat the high score. And if you don't beat the high score, it runs this. That's called nesting. You've got one if statement nested inside the other. And it needs its own curly brackets as well, of course. Okay, the last thing we're going to do just now is modularize this a bit. So, because it's getting pretty long, and it's kind of hard to follow what's going on. So if we make it a bit more modular, then our main method will become a bit more readable. So let's say this is the game, the way to play the game. I'm going to highlight pretty much all of this actually. Now how do I, here we are, refactoring. So if you right click on it and refactoring, you can extract this all into a method and give it a name. So this is play game. Apply the changes. So your main method now just sets up the console's title, plays the game, and then waits for you to press a key before exiting. So all that code went inside the play game method which it created for you. May not seem that much more tidy, but the next thing we're going to do is use a menu. I think I might leave that for the next video as this one is getting on a bit. And that will do for the moment. So that's creating your own methods using refactoring tools to make your code more readable. See you in a bit.